I'm Van Butsic. I'm a cooperative extension specialist and the co-director of the Cannabis Research Center here at UC Berkeley. Today I'm going to talk about some of the research we've done on mapping and modeling cannabis in Northern California. This research started with a really basic question. How much cannabis is out there? Around 2012-2013, there was a number of media reports indicating that there are substantial environmental harms from cannabis production in Northern California. However, none of these reports actually had data documenting how many farms were out there and what type of damage they were doing. So in 2014, working with a large group of undergraduate, graduate students, and postdocs, we started mapping how much cannabis was in Northern California, specifically in the cannabis cultivation hotbeds of Humboldt County and Mendocino County. We've now completed mapping for the years 2012, 2016, and 2018. To do this mapping, we start by identifying cannabis grows on the landscape. We do this using high-resolution satellite data. Essentially, this is the same data that you would see on Google Earth. And indeed, if you go to Google Earth and scroll around Humboldt County or Mendocino County, especially if you look for images from fall dates, so in July, August, or September, you can clearly see cannabis farms. So essentially what we do is we identify cannabis farms. We do this by looking forward and backward in time and seeing where cannabis plants appear and disappear. We do this for both outdoor cannabis gardens as well as greenhouses. Undergraduate students have done most of this work. Basically, they identify where these are, they mark them on a map. We put this all into a computer and we get a digital layer of cannabis farms in Northern California. So we've done this now in 2012, 2016, and 2018, Humboldt, Mendocino County, and we've done this for about half of each county. And we've done this for a statistically representative sample of the county. So we think if you take the statistics I showed today and roughly double them, you'll have a pretty good idea about how many cannabis farms are in Northern California. So from this research, we have some very basic findings. For the first time, we have some idea of what happened during the green rush. And what we saw was that, first of all, the number of farms increased between 2012 to 2018 by over 50% in both Humboldt County and Mendocino County. So we saw a lot more farms on the landscape in 2018 than we did in 2012. The next thing we saw was that all the farms were, on average, getting bigger. So farms increased from on average of about 6,000 square feet to up to about 9,000 square feet. So a large increase in the size of the average farm. So combining the fact that we have many new farms and the farms that were in existence are getting larger, what we see is an overall increase in the square footage of farming by over 100% in both counties between 2012 and 2016. An interesting point is that while the square footage has increased, most of this increase has come from a very specific type of production, and that is production within greenhouses. So the amount of greenhouse area has increased by over 200% in each county. What this means is that the actual number of cannabis plants and the actual pounds of cannabis produced in each county has increased even more quickly than the square footage of production. This is because greenhouse grows oftentimes have multiple crops in one year. Therefore, we expect that the average number or the average amount of cannabis being produced in these two counties has doubled or tripled between 2012 and 2018. A big policy change happened in 2018, and for the first time, cannabis farms needed to be permitted by the state of California and local government and able to be legal. Using our data set, which included both permitted and non-permitted farms, we were able to analyze for the first time how many of the farms were getting permitted. What we saw was that most farms in Humboldt and Mendocino County were not permitted. Only about 20% of greenhouse farms had the applicable permits. However, the farms that were permitted were a little bit larger than the farms that were not permitted. So although only 20% of farms were permitted, these farms made up over 40% of the total greenhouse area. We saw a similar trend for outdoor production as well. Only about 20% of the farms had the required permits, but those farms were the larger farms, and so it accounted for about a third of the overall square footage of production. We were interested in why some farmers had permits and why some farmers didn't have permits. And so we used statistical models to say, are there farm characteristics that lead to farms being more likely or less likely to engage in the permitted industry? We found there was a number of interesting correlations. One was that older farms were more likely to have permits. Another thing we found was that farmers who had invested and grown their farms between 2012 and 2016 were more likely to have permits in 2018 as well. But the overall largest factor that seemed to determine whether or not a farmer entered the permitted market was how large they were. Essentially, if you had 1,000 plus plants on your farm, there's about a 75% chance that you were going to be permitted. At the same time, if you had only 100 plants or less, the odds of you being permitted were somewhere around 10%. So farm size is a strong indicator of whether or not cannabis farmers are going to enter the permitted market. One thing that we were interested in was the spatial arrangement of cannabis grows that we were mapping. This is important for a number of reasons. First of all, from an environmental perspective, it's really important to know if the cannabis grows are clustered in one area. If so, this could have two effects. On one hand, this might mean that the environmental damage from cannabis is more concentrated because they're all being grown in the same place. On the other hand, if the cannabis grows are clustered on the landscape, that might mean that there's large sections of the landscape that actually aren't impacted by cannabis grows. And so there's an interesting trade-off based on the spatial arrangement of cannabis grows. We did analysis at two different spatial levels, looking at both the watershed scale and within the watershed scale. And what we found was that within Humboldt County, there was strong clustering of cannabis farms. Essentially, if you were a cannabis grower, there was a good chance that your neighbor was also a cannabis grower. One thing that we also saw in our data was that between 2012 and 2018, there's a number of farms that went out of business. There's a number of new farms, but we had over 400 farms between 2012 and 2016 that actually stopped producing cannabis. One thing we were interested in about that was it possible that the reduction or the abandonment of these farms had something to do with new environmental policies that the state was introducing, which were designed to make it more difficult for farms in environmentally sensitive areas to farm. We did a bunch of regression statistics, and essentially what we found was it was really unlikely that enforcement of environmental actions contributed to what farms were abandoned overall. There was little correlation between environmental sensitivity and the likelihood that a farm would be abandoned. We looked at what factors were the most important for farms that were abandoned, and once again, we saw that it was the size of the farm was the driving factor. Small farms were quite likely to abandon, large farms were very unlikely to abandon. So once again, we see this dynamic where large farms persist and small farms do not. We're interested in the environmental impacts of cannabis, and one area where there had been quite a bit of press was having to do with forest clearing. So the idea is that there's all these new cannabis farms, they're out in the forest and they're clearing land, they're clearing forest for the farms. And the images you see here are from cannabis farms in Trinity County, in one of the most densely farmed areas of the state, and you can clearly see that there's openings in the forest from cannabis farms. But we wanted to look more systematically and say, could we really see this change from cannabis farms? And then how did it compare to other drivers of deforestation? So in this case, we looked at logging. So we looked at logging permits from 2000 to 2013 in Humboldt County. And we looked at all the new cannabis farms that were established. Then we used remote sensing data to say where was there actually timber harvest or deforestation? Where were the trees removed from the landscape? And then we compared the effects of timber harvest to the effects of cannabis grows. What we found was that timber harvest contributed nearly 10 times as much to removal of forest, removal of trees, than cannabis overall. So the area removed by timber harvest was much greater than the area removed by cannabis farms. And this had larger impacts on most of the sort of scientific ways that we measure forest habitats that are based on what we call fragmentation metrics. So takeaway, in general, timber harvest had a larger effect than cannabis farms. Interestingly, though, if we scale this to the amount of land used for cannabis and the amount used for timber harvest, we found that actually the effect was, on a per acre basis, very similar, and in fact sometimes cannabis had a greater impact on a per acre basis. Finally, we found that in some areas, some watersheds, about 15 out of 60 watersheds, cannabis farms actually contributed more to these forest fragmentation metrics than timber harvest. So while overall timber harvest had a larger impact, in some areas cannabis was actually a larger driver of timber loss. Another thing we should be really clear about is that in California, if you're a permitted timber harvesting organization, you need to replant the trees. It's the law. And so we would assume that in the long term, the forests that were harvested will grow back. It's unclear what happens to cannabis farms in the long term. Do they revert to nature? Do they continue as small farms? We simply don't know right now. So I want to emphasize that the impacts that we're showing here are short-term impacts on forest fragmentation, and what happens in the longer term as trees start to grow back is unclear. Given these results, we wanted to think about how we could develop policy to help mitigate the impacts of cannabis production on the landscape. And to do this, we really wanted to know what drives the location of cannabis production. And when somebody's thinking about entering the market and developing a farm in these Northern California counties, what characteristics are they looking for in the land that helps them, or that leads them to decide where to put a farm? And if we know that, we can think about what land use policies might be most effective at mitigating the harms of cannabis production. So what we did was we ran a number of models, statistical models, basically looking at what parcels in Humboldt County had farms and what parcels did not have farms. And using these statistics, we were able to find some trends in the data which suggest what leads people, or what parcels are most likely to have cannabis on them. One interesting result was that the percent of the parcel that was zoned for agricultural purposes was not an important factor in determining whether or not there was cannabis on the landscape. In fact, the larger percentage of a parcel that was agricultural land, the less likely it was for that parcel to have cannabis. Essentially what we saw was that parcels that were agriculture have stayed in agriculture. They've not converted to cannabis in our data set. Parcel size was somewhat important. The larger the parcel, the more likely it was for cannabis to be on that parcel. But there is one variable that was by far the most powerful at predicting whether or not a parcel had cannabis or not, and that is whether or not the neighbor had cannabis or not. So there's these strong spatial clusters that we identified in our earlier analysis were robust in the modeling framework as well. That is, there seems to be some social conditions that lead to the clustering of cannabis. It's unclear if this is a feeling of protection in areas that has historically allowed cannabis production, if it's a knowledge transfer, one neighbor teaching another neighbor how to grow cannabis, or if there are some biophysical things that we're unable to control for in our model. But overall, it does seem that cannabis farmers tend to cluster, and the best predictor of where a cannabis farm will be is whether or not there's a cannabis farm nearby. So this can tell us a few interesting things from a policy perspective. First of all, this clustering seems to be sort of a social phenomenon more than sort of a biophysical phenomenon. And what this means is that cannabis is being grown throughout the county in many different types of landscapes. This means that there's a good chance that land use policy could be effective in making sure that cannabis is grown on on parcels